The first set of problems I will be doing will be 1 through 4 on page 236. Okay, so the first problem, you have to complete a statement by writing less than, equal to, or greater than. So let's get started with this. So it says, if x is greater than y and y equals, oops, that's not a 2, that's a z. So if x is greater than y and y equals z, and the answer is, then x would be greater than z, because y equals z and x is greater than y, which means x is also greater than z. So they both correspond. Number 2. If a is greater than b and c is less than b, and the answer, then c would be less than a, because a is greater than b, which is greater than c. So c would be less than a, or a would also be greater than c. Number 3. If s equals t plus 4, then s, and the answer, is that s would be greater than t, because s equals t plus 4, so s minus 4 would equal t, so s is greater than t. For number 4, if e plus s equals f plus 4, then and the answer would be e, scratch that, e would be less than f, because f you're only adding 4, but e you have to add 5, so e would be less than f. For the next set of problems, I will be doing questions numbered 7 through 10 on page 236. Okay, so for number 7, we're supposed to complete this statement by writing less than, equal to, or greater than, just like in the previous set of problems. So, if the length of the sides of a triangle are x, 15, and 21, then x must be greater than must be greater than 6 and less than, oh, I screwed that up, whatever, less than 36. And this is because of the statement, the third side of a triangle is always greater than the difference of the other two sides and less than their sum. Cross that out, and that's the answer to number 7. number 8. Numbers 8 through 10, we are trying to prove which segment would be the shortest out of 3 diagrams. So 1 diagram per problem. So label the diagram for number 8, which is a triangle. And we know the third side is, all 3 sides add up to 180. So 57 plus 62 plus 61 is 180. And stated by theorem 6.2, if one side of a triangle is larger than a second side, then the angle opposite the first side is larger than the angle opposite the second side. So, since 57 is the smallest angle, CB would be the smallest segment. Now we label number 9. So, we have 2 triangles opposite of each other. So we find the third angle, which for DGE would be 59, and for GFE would be 63. And since out of all these angles, 55 is the smallest, that would mean that segment GE would be the smallest segment. This was proven because of theorem 6.2. And yeah, the answer would be segment GE. Okay, number 10, final problem of the set. We have another triangle, but it's cut by 2 right triangles. So let's label. And it is already given that segment HK is congruent to segment HI, and since there are 2 right triangles, both of them add up to 180. So 30 and 90 and 31 and 90, that would mean 60 and 59. So the smallest angle out of all of these would be the angle with the measure 30 degrees, and the opposite segment would be segment KJ. The final problem I will be doing is question number 16 on page 237. And question number 16 is a proof. So we start with what's given, which is XS is greater than YS. Also, segment RX is congruent to segment TY. Final bit of information that's given is that S is the midpoint of RT. Okay, now what we have to prove, which is the measure of angle R is greater than the measure of angle T. Now we set up the proof. So we start with the statements, which are on the left, and the reasons, which are on the right. First, we just basically reiterate what was given. So XS is greater than YS. Segment RX is congruent to segment TY. Finally, S is the midpoint of segment RT. And the reason was because it was what was given. And number 2. Well, number 2 is basically, if you look at it, it's basically what we need to prove. So it's only a two-step proof. This one was simple because of theorem 6-2. So we'll label it. And as you see, Rx is congruent to Yt. And since S was the midpoint of RT, that means RS is congruent to ST. So we label it. In the diagram, we can use theorem to state what's the reason. So the measure of angle R is greater than the measure of angle T, angle T, and that's because of theorem 6-2, which states that if one angle of a triangle is larger than the second angle, then the side opposite the first angle is larger than the side opposite the second angle. And that's the final answer.